There are many key drivers for growth of data centers, such as AI revolution, crypto mining, e-commerce, digital transformation, and streaming. Hyperscale data centers are becoming a big proportion of future deployment. Hyperscale data centers are typically designed to accommodate infrastructure demands of large-scale cloud service providers such as Google, Meta, Amazon, and Microsoft. From future hyperscale or AI data center perspective, demand for power is tripling by a factor of 3 due to large language models. Some publications expect that power consumption by these AI data centers can be around 1000 terawatt in 2026. Consequently, these data centers demand high power densities and also best-in-class efficiency to reduce power wastage. For example, in the previous years, data centers were deployed with standard servers with 1 or 2 CPUs with total output power of around 3 kilowatt. In AI servers, there can be 2 CPU, 8 GPU, and 8 DPU with power range in the order of 10 kilowatt. Picture on the right shows such evolution in just the last 2 years. Often data centers are powered from the 20 kilovolt medium voltage transmission line. Power delivery to the GPU rack goes through many power conversions. Power first goes through a traditional transformer and an automated switch control, which is backed up by a diesel generator. By now, the 20 kilovolt line is converted to a 3-phase 400 volt AC. It then goes through a UPS with a battery storage capacity, aiding the diesel generator during power outages. And then the power distribution unit converts the 3-phase 400 volt AC to a single-phase 230 volt AC line at the rack level. At the rack, where the GPU servers are located, rest of the power conversion happens. Total rack power until few years ago was around 30 kilowatt. However, with future AI data centers demanding more power up to 100 kilowatt at the rack level, power solutions of the past fall short. Today, we highlight onsemi's latest solutions that are used in power supply units and intermediate converters in the server rack. onsemi's latest generation M3S 650 volt MOSFETs and T10 silicon MOSFETs in 80 volt, 40 volt, and 25 volt are used in the power conversion from AC to DC and also intermediate bus converters. These devices are used in transforming 230 volt AC line voltage to 48 volt first and then to 12 volt along the power flow. Conversion efficiency is the key here. Maintaining ORV3 specification of 97.5% is very critical in reducing wastage. Further, the same T10 silicon MOSFETs are also used in converting the 48 volt to an intermediate bus voltage of 12 volt to power up the GPU and CPU cores. Essentially, there are 3 power delivery trends: power rating, efficiency, and power density. As can be seen from the left of the slide, power rating is going up. The way to look at this is that rack size stays same along with the power supply units while increasing the power rating. This year, we are seeing deployment of 5 kilowatt designs, and in the next 3 years, we expect an exponential growth in this rating. As a result, we expect the demand for power density increases by nearly 4 to 5x during the same period. Secondly, efficiency is the most important metric here. Until a year ago, industry was targeting 80 plus titanium standard with a 50% load efficiency of 96%. However, we are now targeting 97.5% efficiency at the same 50% load. This is under OpenRack version 3. Moreover, under extreme AI loads, which could be up to 150% load for a fraction of time, efficiency and thermal performance should be acceptable. Solutions that offer high current density, higher efficiency, and are thermally superior will address these needs well. onsemi's 650 volt silicon carbide M3S MOSFETs are used in both PFC and on the primary side of the LLC block. With this, we can enable a peak efficiency of 97.5%. These devices offer best-in-class figures of merit such as RDS on QG, RDS on QoSS, and EoSS, which are very critical for high switching frequency applications. Additionally, these devices can also offer best switching performance in both hard switching and soft switching topologies. Charts on the bottom left show some of these key characteristics of these devices. In hard switch circuits such as PFC, the low specific on resistance and low output capacitance gives us better reverse recovery charge and low EoSS. This in turn reduces switching turn-on losses in the application. Secondly, QG of the 650 volt M3S devices is lowest, which helps in reducing gate drive losses. Significantly better light load performance is expected due to low EoSS, which is very critical for ORV3 standards. As a result, overall efficiency is much better than competitors. Similarly, using onsemi T10 silicon MOSFETs on the secondary side of the LLC block, we can also enable a peak efficiency of 97.5%. Further, the same technology devices are used in the intermediate bus converter module with an efficiency of 98% with a power density of around 5 kilowatt per cubic inches. These devices are also offered in a dual cool package technology that helps in heat extraction from both sides, resulting in superior thermal performance. All of onsemi T10 silicon MOSFETs are used in soft switching topologies where RDS on QoSS metric is most important. Charts on the bottom left show T10 MOSFETs performance against competition. For both the 80 volt and the 40 volt platforms, we see that onsemi devices show at least 20% better performance, whereas the 25 volt platform, we can see that improvement is around 30%. As a result, overall efficiency of the power supply unit and the intermediate bus converter is much better. Finally, on this slide, we show onsemi's portfolio of products that are suitable for any AI data center PSU and IBC designs. On the left, we have 650 volt M3S MOSFET portfolio ranging from 12 milliohm to 32 milliohm on resistance devices, offering in standard TO247 4 lead, TO leadless, and D2PAK 7 lead packages. On the right, we have T10 80 volt silicon MOSFET portfolio offered in 5 by 6 mm dual cool, single side cool, and 3 by 3 mm dual cool products with an on resistance from 1.4 milliohm to 4 milliohm. In addition, we also offer 1.3 milliohm 40 volt MOSFET and 0.7 milliohm 25 volt MOSFET in 3 by 3 mm dual cool packages as well. With such a wide portfolio of products, onsemi is in a position to address most AI data center power needs.